Hello, this will be the video going through how to write chemical equations. Okay, so step 1 is to write down the correct formula of all the compounds in the equation. So if you still do not know how to write chemical formulas, please refer to the previous video. Second, you may need to write down the number of atoms on each side of the equation, but after some practice, you can do this in your mind. Okay, then that will hopefully make you faster and faster. Next, we look for elements that have different number of atoms on each side. We balance by multiplying the species. So this is where your concept of lowest common multiple come in again. Okay, so the tip for you is that you can try balancing in the following order. We start with the metals, then we go to the ions, then we look at non-metals, and we look at H and O. We check that all elements have the same number of atoms on both sides. If not, we need to keep repeating, okay, to try and balance again and again. Now, one thing is students sometimes tend to multiply so many times that actually you can divide throughout by like say 2. Okay, so just take note that at the end of writing your equation, check that they do not have any common factor. Yes, math again, right? Let's start. Let's look at the first equation. Hydrogen plus nitrogen gives you ammonia. So the first step is to write their formula. And if we look at the periodic table, remember we mentioned that some of these gases, some of these actually exist as diatomic molecules. Hydrogen, nitrogen, oxygen, and group 7, right? So we know that hydrogen should exist as, let me use blue, H2. Nitrogen also exists as N2. Ammonia is a formula that you need to memorize, NH3. And let's see on each side of the equation how many of each atom are there. Okay, on the left side I have 2 hydrogen, 2 nitrogen. On the right side I have 3 hydrogen and 1 nitrogen. Can you see that both H and N are not balanced? So how do I balance it? If you look here, 2 and 1, what's their lowest common multiple? It will have to be 2, correct? So I need to multiply the right hand side by 2. In doing so, I would change this number to 6 hydrogen and 2 nitrogen. So you can see that nitrogen is balanced. Then I look at 6 hydrogen and 2 hydrogen. What's their lowest common multiple? That's right, it's 6. How to get 6? I must multiply by 3. So this is the, okay, haven't updated yet. So times 3, right? 3 times 2, because there's 2 hydrogen, so that's 6 atoms of hydrogen. Okay? So when you add these together, you end up with 2 ammonia. Now, why is that the case? It's because we can't create nor destroy atoms. Everything must come from something, right? So therefore, I must account for each and every single atom that was there. Now, the last step is to write the state symbol, which is in your syllabus. So how do you write the state symbols? You need to know that hydrogen exists as a gas at room temperature. Nitrogen also exists as a gas at room temperature, is in our air. And ammonia also exists as a gas at room temperature. So this is straightforward. Next, we have a combustion reaction. Methane plus oxygen gives me carbon dioxide and water. So there are more formulas that you have to memorize here. Methane is CH4. Oxygen is a diatomic molecule, so it's O2. Carbon dioxide, carbon with 2 oxygen, so it's CO2. And water, which you need to memorize, H2O. Okay, so now it's slightly more complicated. Let's try counting. There are 3 elements this time, C, H, and O. On the left hand side, I have 1C, 4H, and 2O. Okay, on the right hand side, I have 1C, 2H, and 3O. Okay. Can So, which do I balance first? Right, C seems like it's done, so I don't touch C. And if you look here, between H and O, we go for H first. So let's try balancing the H. Okay, is 2 here, 4 here, lowest common multiple is 4. So which should I multiply? I need to multiply this right hand side by 2. Then let us update the numbers. This means total number of hydrogen on the right hand side is now 4. Then now there's 2O here and 2O here, so there's 4 oxygen. Okay. On the right hand side, there's only 2. So lowest common multiple again is 4. So therefore, this time I multiply on the left hand side, this oxygen I must times 2. This will update it to 4. Can you see that now every element is balanced? So this is the balanced chemical equation. Now let's try and add the state symbols. For methane, it is a gas at room temperature. Same for oxygen. Same for carbon dioxide. For water, it exists as a liquid. Next, C. Aluminium plus nitric acid gives you aluminium nitrate solution and hydrogen gas. So, how do we do this question? Aluminium is a metal. And recall that metals, the formula is just this name. Okay, it's just chemical symbol. Nitric acid is something that you may need to memorize. Now note that acid must always contain H+. And what is nitric acid made of? Nitrate ions. So if you know that this is H plus is 1 plus, nitrate is 1 minus, you can deduce what's the formula of nitric acid, which is HNO3. It forms aluminium nitrate solution. So this time I need to go to my periodic table, look for aluminium here, and nitrate. Just now I wrote the nitrate formula already. So aluminium will form Al3 plus. Can see? Because it's in group 3. Forms a 3 positive charge. So this is Al3 plus. Nitrate is NO3, 1 minus. If I look at the charge, I can see that I will need to times 3 here. Okay, so therefore, Al, when I multiply polyatomic ions, bracket the whole thing, multiply by 3. Okay, and hydrogen gas, again diatomic, so H2. Now, I hope so far so good. At least your formula must be correct. Okay, let's try and count. Now, what I like to do is I like to count the ion by ions. Okay, that's to say polyatomic ion with polyatomic ion. It's easier to count. Okay, so first I have 1 aluminium, 1 hydrogen, and 1 NO3. Okay, I just group it together. On the right hand side, I have 1 aluminium, 2 hydrogen, and 3 NO3. Okay, so what should I balance first? Again, if you go to this rule, you'll see that between metal was already balanced, right? My aluminium was balanced already. Next is ions. Okay, so if I look at my nitrate, can you see that this is not balanced? This is 3 and this is 1. It is the lowest common multiple would be 3. So this one times 3. So I put a 3 here. This one also must times 3. Now the H don't balance. Okay, left side is 3, right side is 2. How to make it the lowest common multiple? Must make it 6, right? So this one must times 3, put 3 here. This one must further times 2. Okay, so this one become 6. Now when it becomes 6, right, further times 2, means this one also must further times 2 leh. Right, this 6 affects this nitrate. Then how? Then this one also must times 2 lor. Okay, so this one times 2 by putting a 2 here, means this one must times 2 also leh. Then how? Then this one I times 2 also lor. Put 2 here. So this is the balanced chemical equation. Okay, this one took quite a bit of back and forth for us to get the balanced chemical equation, but I hope you can see the thinking process behind it. Okay, I started with the ion, then I moved to hydrogen, and then at the end I see that that will result in my metal not being balanced, so I went to the metal. Okay, and check. They can't be divided throughout by the same number, so this is it. Let us add the state symbol. Metals are solid at room temperature. Acids are in aqueous state. Okay, what is aqueous state? Aqueous means dissolved in water. It's a solution. And what is the difference between aqueous and liquid state? Okay, this one student always ask. Aqueous versus liquid. Think about a solid. Okay, for a solid to go to a aqueous state means I need to add water. What about when I want a solid to get to a liquid state? I need to heat it up till above boiling point. Yes, then it will become a liquid, right? Wait. Above melting point. Boiling point, then become gas already. Okay, heat until above melting point. So can you see the fundamental difference between the two? One requires heat, is the same substance changing state. One is I add it to a solvent. Okay, so it's not a change of a state in that sense. It's just dissolved in water. Okay. So an acid must be dissolved in water, because if not, it will not give me the free moving H plus ions. Okay, here, note that the carbon dioxide is on this side. Sorry, the printing not very good. Okay, let's try and do this. Iron 3 carbonate. Iron is transition metal, tells me the charge 3 plus. Carbonate CO3 2 minus. So how to write the formula? I need to change color. I need to times 3 times 2 times 3 times 2 times 2 times 3. Okay, so how times 2 times 3? I must put a 2 behind here. And I must bracket and put a 3 behind. Hydrochloric acid, again you can use the same method. There must be H plus, and hydrochloric acid, the anion is Cl minus, so the formula is HCl. Iron 3 chloride, again iron 3 Fe3 plus, chloride is Cl minus, so 3 plus and 1 minus, so I must Fe3 plus Cl minus, so Cl must times 3, Cl3, and water is H2O, carbon dioxide CO2, carbon with 2 oxygen. So this is the equation. Let me just write this in blue. Okay. Now what is this reaction? It's an acid carbonate reaction. Gives you salt, water, and carbon dioxide. So how do I balance the equation? Now what I'll do is, again, I will balance the metals first. In this case, can you see that there's 2 iron here and only 1 iron here? So definitely I need to times 2 here. Okay, this brings me to have 6 chloride ions in total, right? On the left hand side, there's only 1. So I need to times 6 minimally. So whenever I multiply one thing, right, you'll notice that it will affect something else because it's grouped together. So after I make chlorine 6, I also made hydrogen 6. Okay, but on the right hand side, there's only 2 lah. So how do I make 2 6? Must times 3. Okay, and you can see that now, what else did I affect here? I affected the number of oxygen. Okay, so then we look at oxygen lah. On the right hand side, I have, oh no, there's still one more that I haven't balanced yet. Oxygen, we try and leave to the last. If you see the rules here, oxygen, we try and leave to the last. If there are other non-metals, we try and balance that first. And in this case, that will be your carbon. Can you see these 3 will multiply in? So actually on the left hand side, there's 3 carbon. On the right hand side, there's only 1. So I must multiply by 3 here. Okay, finally, let's do an oxygen tally. It's very confusing because oxygen appear multiple times. Oxygen tally, 3 times 3, there's 9 oxygen here. On the right hand side, 3 oxygen and 3, there's 3 O here, and there's 6 oxygen here. So total 9 oxygen. Okay, looks like 90, but you know what I mean now, huh? 9 oxygen. Okay, write smaller. Okay, so balance. Yay. Now let's write the state symbols. Iron 3 carbonate. Carbonates are generally insoluble, so this is a solid at room temperature. If I add it to an acid, again all acids are dissolved in water for it to become acidic. For it to be acting as an acid, so it must be dissolved in water, aqueous. On the right hand side here, I wrote solution, so you know it's a aqueous, water, liquid, carbon dioxide is gas. Next, ammonium nitrate and lime water. Ammonium nitrate, NH4 plus, nitrate NO3 minus, is NH4NO3 since the charges balance. Lime water, I purposely did not write down the chemical name so as to test your memory to see whether you remember what's lime water. Lime water is calcium hydroxide, so Ca2 plus, hydroxide OH minus, so Ca bracket OH2. Calcium nitrate, calcium is group 2, Ca2 plus, nitrate NO3 minus. So not balanced yet, I need to times 2 to the nitrate. So calcium nitrate times 2. Ammonia gas, NH3, water, H2O. Okay, let's try and balance. First thing to balance is metals. Metals on both sides, I have 1 calcium, settle. Okay, then next, let's try and balance ions. Now I can see that nitrate on the right hand side there's 2, on the left hand side there's only 1. So I will try and multiply here by 2 for the nitrates to balance. Can you see where did the NH4 go on the right hand side? Yes, most of it became a NH3. So if there's 2 NH4 on the left hand side, there should also logically be 2 NH3 on the right hand side. Now where did the missing H go? Can you see that? One of the H reacted with the OH to form H2O. So, okay, doesn't matter if you can't get it, huh? How many H are there in total? Wow, this one hard to count. 4 here, 2 here, 6 on the left hand side. Then on the right hand side, I have 6 plus 2, 8. Oh, right hand side got more. wait, there's 8, 10. This one right hand side, and let me write down lah. Okay, there's 8H here, and there's 2H here, 10. On the right hand side, there's 6 here and 2 here, so there's 8 only. So I need 2 more hydrogen. Where do I get 2 more? I put a 2 here lah, then multiply by 2, so this would be 4. Then left hand side, right hand side, add up to 10. Okay, balance. Let's look at O. We always look at O last. So O, there's 2 times 3 here, so there's 6O, and then here plus 2, 8O in the left hand side. Here there's 6 plus 2, 8 on the right hand side, so balance already. Okay, let me cancel all these now. Very messy. Okay, now let's add state symbols. Ammonium nitrate. All ammonium and all nitrate salts are soluble, so they are typically in aqueous state. Lime water is calcium hydroxide in aqueous state. Calcium nitrate solution is a solution, so it's in aqueous state. Ammonia gas is a gas, so it's a gas. Water is water, so it's liquid. Okay, coming to an end. Okay, hydrochloric acid, again H plus, Cl minus, so the formula is HCl. Magnesium, notice that it is magnesium on its own, so as a metal, its formula is just Mg. It forms magnesium chloride, Mg 2 plus, Cl 1 minus. For charges to balance, I will need MgCl2. Okay, hydrogen gas exists as H2. So now let's try and balance. Okay, let's look at metals first. Mg, settled. Okay, then let's look at chloride ion, Cl1, Cl got 2 here. So how? Times 2 here. Then let's look at H, 2H on the left hand side, 2H on the right hand side. Great. So this one, done. Let's add state symbols. Aqueous state here, because it's an acid. Magnesium is a solid. Magnesium chloride is aqueous. And hydrogen gas is a gas. So this is the final equation. Last but not least, and this is something that you will see when we do qualitative analysis, a property that we make use of. Okay, copper 2 sulfate. Copper is a transition metal, so it tells you the charge here, Cu2 plus, sulfate is SO4 2 minus. So you can see that the charge balance already, therefore CuSO4. Sodium hydroxide, Na plus, hydroxide OH minus, balance already, NaOH. Copper 2 hydroxide, Cu2 plus, OH minus, I need 2 times 2 to the hydroxide, CuOH bracket 2. Sodium sulfate, Na plus, SO4 2 minus. Again, you need to multiply by 2 to sodium. Okay, let's check if they are balanced. Let's start with the metals first. As usual, we see that copper is the same, so done. Then we look at the other metal, which is sodium. There's 2 on the right hand side, 1 on the left hand side, so I must times 2. Okay, then we look at the ions. Do the big one first. Sulfate, 1 sulfate on the right hand side. Done. Hydroxides, 2 hydroxide here and 2 hydroxide here. Done. Okay, so it's balanced. Can you see that when you group polyatomic ions together, it becomes easier to balance? Okay, then let's add the state symbols. First, for sulfates are typically soluble, so it's in aqueous state. Hydroxides are also soluble. hydroxides are generally insoluble, but is a group 1 hydroxide. All group 1 salts are soluble. So aqueous, copper 2 hydroxide. Hydroxides tend to be insoluble except if it's group 1 or ammonium. So therefore, this is a solid, insoluble. And again, group 1 salts are always soluble, so this is in aqueous state. Okay, so you need to revise your solubility rules. With that, I end this video. Thank you.